In this video, I will show you how we can use an external reducer to reduce bug-inducing test cases that we have found using SQLancer. So you can see that I'm already at a repository, namely the one of CReduce, which I will be using to demonstrate this. So CReduce was originally developed for reducing C and C++ programs, but actually it also works reasonably well for other kinds of inputs. By the way, if you're interested in how CReduce and other reduction tools work under the hood, I would recommend you to check out the debugging book, which is an interactive way of learning how different debugging techniques, including, for example, the delta debugging algorithm, which is very important for test case reduction tools, works. Right, so now assume that you've already installed and set up CReduce before starting. Now let's go to my SQLite folder here. And as you can see, I'm currently operating on an older version of SQLite because I've run SQLancer previously on this version and identified some bug-inducing test cases that we can now reduce. Let's take a look at the bug-inducing test case here. You can see here that SQLancer basically indicates that it executed this SQL statement, and then you can see that it triggered an unexpected error. Right, just to remind you at a high level, what are expected errors? If we go here to the SQLancer repository and open the insert generator class for SQLite, you can basically see that we declare various errors as expected. So these are some errors that we cannot easily prevent during runtime. So rather than that, we declare them as errors that we might expect. And if you indeed encounter them, then basically SQLancer will ignore them. But if one of these errors was not declared, then we consider it an unexpected error and consider it as a bug, such as in the example here. And so in this case, the database disk image is malformed, indicates some kind of integrity violation or website database corruption. As you can see here, the test case is not too long, but still not small enough to immediately analyze and determine the root cause. Right? So before reporting this kind of bugs, we should make sure that we extract a minimum version that makes it more easy for developers to analyze them and for us also to understand them. So first of all, let's try to execute the test case here. For this, I'm passing the input here to SQLite. As you can see, first of all, we can actually see various errors being triggered, but these are all expected errors. The unexpected error is here below, which indicates that the database disk image is malformed. Now, next, we need an interestingness test that actually tells us whether the bug is still being triggered. As you can see, I've already written such an interestingness test, which basically passes the script to SQLite and then checks whether the string malformed is still part of it. Now here, this interestingness test actually depends on the kind of error that or the kind of bug that we still want to trigger. In this case, for unexpected errors, we might directly grep for the error message. If, for example, the process crashes, then we need to check for the execute. And in the case of errors where, for example, TLB indicates that two queries produce different results, then actually we also need to check for this, right? We would basically need to have the two queries here in the interestingness test, send to the system and check whether they produce different results. Yeah, so what we can do now is we can invoke CReduce. Let's forget the order. So CReduce first expects the interestingness test here, and then the file to reduce. Or the file is not executable, so let's make it executable first. And now you can see that CReduce is reducing the file. It actually already reduced it a lot, right? So if you compare to the original version, which had more than 6,000 bytes, and now we are already down at a minimum version. Yeah, you can basically check that now it's only 4 statements. We can test again now if we can actually still reproduce the bug. Yeah, and as you can see, it's still the case. Of course, sometimes we can actually still reduce things a bit more. For example, here we could try to reduce the constant a bit. The bug actually still triggers, but overall we already reduced the size significantly. So now after some more manual redaction, we could actually report the bug to developers. Now finally, a short high-level discussion on the current state of reduction in SQLancer. So we have an internal reduction tool that works. For some cases, it's not very complete yet. And in the long term, we also want to integrate such external reduction tools into SQLancer. A challenge there is that basically when a SQLancer finds a bug, it not only needs to remember the bug-inducing statements, which it currently does, but it also needs to remember some more information about the state, which then helps us to automatically synthesize this interestingness test. So currently, we still need to write this interestingness tests, which can be quite tedious and quite tricky for example, checking for equivalences of queries. Okay, thanks everyone for listening.